Welcome to the deep dive. Today we're shining a light, quite literally, on something absolutely fundamental to all of us, natural light. You know, sunlight and moonlight. It's this influence that's so profound, and yet, well, we often just take it completely for granted, don't we?
Absolutely, yeah. And for this exploration, we've really looked far and wide. Our journey through the sources, it takes us from like the core biology and the physics of light itself, all the way to how we think and feel in psychology, how societies has evolved, anthropology, history, even a touch of philosophy.
Philosophy, too.
Yeah, to sort of consider our place in this grand cosmic dance of light and shadow.
Exactly. So our goal here really is to pull out the most crucial insights, how sunlight and moonlight shape our very being, our bodies, our minds, our cultures.
Yeah.
And also to get a handle on the challenges that our modern world, filled with artificial light, presents. Think of this as your fast track to understanding this really essential connection.
And what's truly striking, I think, is just how universal this influence is. It doesn't matter who you are, where you're from, or when you lived. The presence and absence of natural light have been this constant, powerful force in your life, like a thread connecting all of us.
And we've definitely uncovered some truly eye-opening things along the way. We'll be looking at the specific way sunlight helps our bodies make vitamin D.
The mechanism.
How that blue light from our devices can really, throw off our sleep.
Yeah, it's a big one.
And even some of the more subtle, maybe surprising ways the moon might still be influencing us. So, okay, let's dive in.
Let's do it.
Okay, let's unpack this then, starting with the sun. Its absolutely vital role in keeping our bodies functioning properly.
Right. Sunlight is, well, it's essential. And that connection to vitamin D is probably the one most people have heard about.
Yeah.
So when a specific part of the UV radiation from the sun, think of it as a particular energetic ray, hits our bare skin.
Bare skin, okay.
Yes, bare skin. It starts this fascinating chemical process. It converts a substance already in our skin into like a precursor to vitamin D.
Okay.
Which then sort of naturally transforms into the active vitamin D our bodies can actually use.
It's almost like our skin is a little solar-powered vitamin factory.
Exactly. That's a great way to put it. And vitamin D, it's not just about strong bones anymore, is it? That used to be the main focus.
Right, I remember that.
Yeah, while its role in helping us absorb calcium for healthy bones is, totally established, research now also suggests it might play a part in other really important areas, like our immune system, maybe mood regulation, even helping maintain healthy blood pressure.
Wow.
But here's a really key thing to remember. This vitamin D production needs direct sunlight on your skin. It doesn't happen through a window. Glass, you see, it blocks those specific UVB rays that kickstart the whole process.
That's such a good point. So all that lovely sunshine streaming through my office window right now isn't actually helping me make vitamin D.
Nope. Afraid not. Feels nice. But biologically, not for vitamin D.
Okay, so if we do get direct sun, how much do we actually need? It feels like the advice is always kind of shifting.
It is a complex picture, yeah. And giving one-size-fits-all advice is, well, it's really difficult because so many things are at play.
Like what?
Well, the time of day makes a difference. The season definitely does. Where you are geographically, your latitude. Even the things like cloud cover, pollution levels, smog, and importantly, the amount of melanin, pigment in your skin, that all affects how much vitamin D your body can make.
Right, and sunscreen too, I assume.
Oh, because sunscreen.
Yeah.
Which is, absolutely crucial for protecting against skin cancer and premature aging.
Definitely.
But it also blocks those vitamin D producing UV rays. So, yeah.
Right, so it's a real balancing act then. What's the sort of general understanding now? Is there a ballpark?
Well, some experts suggest that for many people, short periods of exposure might be enough. Maybe something like 5 to 30 minutes on your face, arms, and legs. Maybe a couple times a week without sunscreen. But, and this is key, this needs to be adapted.
How so?
Depending on your skin tone, people with darker skin need more time, and also how strong the sun is where and when you are. If you're further from the equator or it's winter, you'll likely need more time.
Got it.
What's kind of interesting, though, is that our bodies have a built-in safety mechanism. We can't actually get toxic levels of vitamin D just from sun exposure.
Really?
Yeah, beyond a certain point, our body just starts to break down any excess pre-vitamin D it makes, so it self-regulates.
That's good to know. But it sounds like despite this, a lot of us still aren't getting enough vitamin D.
That seems to be the case, yes.
Especially considering how much time we spend indoors these days. Is this becoming like a silent public health challenge? And are people looking at ways around it?
That's a very insightful question.
Yeah.
And yes, studies in countries like the U.S., Australia, New Zealand, they do indicate pretty widespread vitamin D deficiency across various age groups. It really highlights this mismatch between our modern, mostly indoor lives and what our bodies actually evolves needing, which is regular sun exposure.
Yeah.
We're quite rightly focused on sun protection, but we might be inadvertently limiting this really vital biological function. As for solutions, yeah, people are looking at things. Public health campaigns promoting safe sun exposure, food fortification, developing better vitamin D supplements. It's an ongoing area.
Okay, so sunlight is absolutely vital for vitamin D. What's the next key biological role we need to understand?
Okay, the next crucial area is how sunlight regulates our internal 24-hour clocks, our circadian rhythms.
Ah, the body clock.
Exactly. These rhythms control our sleep-wake cycles, but also loads of other bodily processes. And again, sunlight is the main conductor, particularly the blue light it contains.
Blue light, right? That's what we always hear about from our phones and tablets, isn't it?
Precisely the same stuff. We have these specialized light-sensitive cells in our eyes. They're called IPRGCs, but you don't need to remember that. They're particularly attuned to this blue part of the light spectrum, around 400, 500 nanometers. When these cells detect that blue light, they send signals straight to a master control center in our brain. It's in the hypothalamus, often called the SCN, or the body's main clock.
Okay, so blue light hits the eyes, signals this master clock. What happens next? What does the clock do?
Right, so this master clock then helps to suppress the production of melatonin.
The sleep hormone.
The sleep hormone, exactly. Melatonin is normally produced by the pineal gland at night, and it makes us feel sleepy. So during the day, when we're exposed to sunlight containing blue light, melatonin production is kept low.
Ah, so that helps us feel alert and awake.
Precisely. And it also helps synchronize our internal clock with the actual day-night cycle of the outside world. Keeps everything aligned.
That makes perfect sense, really. Light signals wakefulness, darkness signals rest. Seems pretty straightforward when it's just natural light.
Yes, the natural contrast is absolutely key. As evening approaches and the blue light in sunlight diminishes, melatonin levels naturally start to rise, signaling our bodies, okay, time to prepare for sleep. And while blue light has the strongest effect, it's worth noting that, normal white light, which contains all the colors, including blue, also has this alerting effect.
Okay.
Red light, on the other hand, seems to have very little impact on these particular light-sensitive cells. So daytime exposure to bright white light can actually be pretty beneficial for alertness and even mood.
But then our modern evenings come along and throw a wrench in the works, don't they?
They really do, exactly. The widespread use of electronic devices, smartphones, computers, tablets, TVs, all of which emit significant amounts of blue light, it completely changes the equation.
How so?
Well, using these devices in the hours leading up to bedtime can seriously disrupt our natural sleep-wake cycle. The blue light basically suppresses melatonin production, essentially telling our brains it's still daytime, even when it's, 11 p.m.
Right, confusing the signals.
Totally confusing the signals. This can lead to trouble falling asleep, poorer quality sleep when you do nod off, and potentially a whole range of other health issues linked to chronically disrupted circadian rhythms.
Like what kind of issues?
Things like problems with metabolism, potentially contributing to obesity or diabetes, cardiovascular issues, even effects on neurological function. It's a really clear clash between our modern tech habits and our, deeply ingrained biological programming.
Wow. I know I'm definitely guilty of late night scrolling sometimes. It's quite eye-opening to understand the direct biological impact that's having.
It is, isn't it?
It's like our bodies are getting these totally conflicting messages. Sunlight says wake up, but our late night phone use is shouting, nope, still daytime.
Okay, so sunlight regulates our sleep-wake cycle via blue light. What about our mood? We often feel happier on a sunny day. Is that just, a feeling, or is there more to it biologically?
Oh, there's definitely more to it. Sunlight exposure is also closely linked to the production of serotonin.
Ah, the feel-good chemical. Exactly. Serotonin is a crucial neurotransmitter in our brain. It plays a vital role in regulating our mood, feelings of well-being, happiness, even our ability to focus.
So how does sunlight affect it?
Well, when we're exposed to sunlight, it actually triggers the release of serotonin in the brain. This contributes to that positive feeling, that increased alertness we often experience on a bright day. So it's not just in our heads. There's a direct neurochemical connection happening.
So logically then, less sunlight could actually lead to lower levels of this serotonin.
Precisely. And that's thought to be a key factor in why some people experience seasonal affective disorder, or SAD.
Right, winter depression.
Yeah, that recurring depression that's linked specifically to the reduced daylight hours in fall and winter. Research suggests that sunlight might influence certain molecules in the brain that help maintain normal, healthy serotonin levels.
Yeah.
So less daylight might disrupt this natural balance, leading to lower serotonin activity during those darker months.
And does the vitamin D we talked about earlier play any role here? Does it connect to mood as well?
Interestingly, yes, there's some evidence suggesting that vitamin D, which, remember, our bodies produce thanks to sunlight, might also help promote serotonin activity.
Ah, so it could be a double whammy.
It could be. It hints at a potential sort of synergistic effect, where both the sunlight itself and the vitamin D helps us contribute together to better mood regulation.
Okay.
Ultimately, it really seems that adequate exposure to natural light is just a fundamental need for maintaining a healthy neurochemical balance and supporting our mental well-being. The link between reduced sunlight and mood disorders like SAD really underscores just how significant this impact is.
Okay, so sunlight is clearly a biological powerhouse. Vitamin D, circadian rhythm, serotonin, mood, it's doing a lot. Now let's turn our attention to its quieter companion, moonlight. We hear all sorts of tales about the moon affecting us, lunacy and all that. Is there any actual science behind any of that?
That's a fascinating area, and it's absolutely true that throughout history, many cultures have held really strong beliefs about the moon's influence. From that old idea of lunacy, the word itself has lunar roots.
Yeah, luna.
To agricultural practices that were traditionally tied to the moon's phases. Now, scientifically speaking, the direct biological effects of moonlight on humans aren't nearly as clearly understood as those of sunlight. It's much fainter, for starters.
Right.
However, there is some emerging research suggesting the moon might have subtle effects on other biological systems, not just humans.
Interesting. What kind of effects are we talking about? In, plants or animals?
Yeah, exactly. We see examples there. Some studies have shown that even brief exposure to full moonlight can trigger changes in the growth patterns of certain plants, like mustard plants.
Huh.
There are also observations, older observations mainly, about increased sap flow in trees as the moon approaches its full phase. And then in the animal kingdom, it gets clearer. Nocturnal bull ants, for instance, actually use the patterns of polarized moonlight to navigate.
Wow, navigate by moonlight.
Yeah, and African dung beetles use it for orientation, to roll their dung balls in a straight line.
That's amazing. So, okay, if other organisms are clearly responding to moonlight, even faint moonlight, does that suggest there could be subtle effects on us too? Maybe something we're not really aware of?
It's a reasonable question to ask, definitely. The fact that various species have evolved ways to respond to moonlight, even though it's so much fainter than sunlight, does suggest that subtle biological effects in humans aren't impossible. But it's really important to be clear here. Strong, rigorous scientific evidence for direct, significant effects of moonlight on complex human behaviors, things like mood swings or violence. The lunacy stuff, that evidence is very limited or largely debunks his ideas.
Okay, so no werewolves confirmed by science.
Not yet, no. But given the persistent cultural beliefs across so many societies, it's certainly an area that continues to spark curiosity and some research.
What kind of research? What are people finding, if anything?
Well, one recent study, for example, looked at sleep patterns in different communities. They compared people in rural settings in Argentina with very limited artificial light to college students in the U.S. with plenty of artificial light.
Yeah.
And they found that, interestingly, people in both groups tended to go to bed later and sleep for slightly shorter periods in the days leading up to a full moon.
Huh. Even the city students.
Even the city students.
Mm-hmm.
It hints at a possible subtle synchronization with lunar cycles. Maybe a kind of leftover ancestral adaptation from a time before electricity, when moonlight was the only significant source of nighttime illumination, potentially allowing for more activity.
Right. Maybe extending the social day a bit on bright nights.
Exactly. Interviews in some communities suggested increased social activities on moonlit nights, elders reporting hunting or fishing enabled by the moonlight.
So while the idea of the moon causing, dramatic changes in behavior might be more folklore than fact.
Yeah, largely.
There could still be this more subtle, maybe underlying influence on our sleep rhythms. possibly linked to our evolutionary past.
That's a plausible hypothesis, yes. A subtle synchronization with rest activity cycles tied to historical nighttime light availability. Not dramatic, but potentially there.
Okay, that's fascinating. Now, let's zoom out a bit and look at the broader impact. Beyond the biology, how have the sun and moon shaped our actual cultures and societies throughout history? Their symbolic meaning must be huge.
Oh, immense. Absolutely immense. The symbolic and religious significance of the sun and moon across human history is just profound. They've been worshipped as gods. They've represented fundamental principles of the cosmos. They've provided a framework for understanding the world and our place in it.
Can you give us some specific examples? How did different cultures view them?
Certainly. I mean, think of ancient Egypt. The sun god Ra was absolutely central, representing power, creation, life itself. But the moon was also vital, with gods like Thoth associated with its cycles, wisdom, and timekeeping. Khonsu was another moon god.
Right.
Then you go to Greek mythology. You have Helios, the sun personified, driving his chariot across the sky, and Selene, the moon goddess. Later, these roles were often associated with Apollo and Artemis, representing a kind of balanced light and dark, brother and sister.
Okay.
Move over to China. The sun and moon are fundamental to the concept of yin and yang. Sun is yang, masculine, active, bright. Moon is yin, feminine, passive, dark. They represent these opposing, yet totally complementary forces that govern everything. And the Mid-Autumn Festival, celebrating the full moon, is still a huge cultural event there.
Yeah, mooncates.
Exactly. In Hindu mythology, you have Surya, the sun god, and Chandra, the moon god, both powerful deities influencing time, rituals, and the cosmic order.
And indigenous cultures.
Across countless indigenous cultures worldwide, the sun and moon are often personified as ancestors, heroes, or powerful spirits. They're frequently woven into creation stories, sometimes seen as siblings or spouses, guiding human life. The specific stories vary enormously, but the importance is constant.
It's amazing how consistent those themes are. Power, cycles, balance, guidance, even across totally different cultures.
It really is. It speaks to how fundamental these celestial lights are to the human experience wherever you are.
So, beyond their deep symbolic meaning, how did the sun and moon have really practical applications in early societies? Timekeeping must be a big one.
Absolutely fundamental. Their predictable cycles were the basis for almost all early timekeeping and calendar systems. Ancient civilizations meticulously observed the sun's daily path and its yearly cycle, the solstices, the equinoxes, to create things like sundials for telling time during the day, and solar calendars, which were essential for agriculture, knowing when to plant, when to harvest. And the moon's regular phases, waxing and waning over about 29.5 days, provided a really convenient way to mark shorter periods. This led to the development of lunar calendars, used by many cultures for tracking months and festivals.
And sometimes they tried to combine them, right?
Yes. Many cultures, like the ancient Chinese or Hebrews, developed lunisolar calendars. These were sophisticated systems trying to synchronize the lunar months with the solar year, often by adding intercalary or leap months. This ability to track time and seasons accurately was just crucial for organizing everything: agriculture, religious ceremonies, social events, everything.
Okay, timekeeping makes sense. What about finding your way around? Navigation before GPS must have relied on the sky.
Heavily. Navigation was almost entirely dependent on the sun, moon, and stars for centuries, both on land and especially at sea. Ancient mariners, think Phoenicians, Greeks, Polynesians, developed an incredibly deep understanding of celestial movements to determine their position and direction.
How did they do that, practically?
Well, by the time of the Great Age of Exploration, celestial navigation became a much more formal science. Sailors used instruments like the astrolabe, or later the sextant, to measure the altitude of the sun at noon, which allowed them to calculate their latitude, how far north or south they were.
And the moon.
The moon played a role, too, especially in the tricky problem of determining longitude, how far east or west you were. Before accurate clocks or chronometers were common on ships, sailors used a complex method called lunar distances. It involved measuring the angle between the moon and specific stars.
Wow, that sounds complicated.
It was, but it worked. And even today, celestial navigation using the sun, moon, and stars is still taught as a vital backup system for sailors and aviators in case modern technology fails. The ability to use the sun and moon as guides literally shaped global exploration, trade routes, and the whole history of cultural exchange.
That's incredible. And I know there's still this belief, you hear about it sometimes, about planting by the moon. Does that have historical roots too?
Oh, absolutely. The tradition of aligning agricultural practices with the phases of the moon, often called lunar gardening or biodynamic farming in some forms, is very old and found in many, many cultures.
What's the basic idea behind it?
The core idea is that the moon's gravitational pull and its different phases, waxing full, waning, new, and sometimes even its position relative to astrological constellations, can influence things like seed germination, root development, leaf growth, and fruiting in plants.
How? Is there a proposed mechanism?
Some theories suggest it relates to the moon's gravity affecting the movement of water, like moisture levels in the soil or sap within the plants, similar to how it affects ocean tides, but obviously on a much smaller scale.
Okay, so what would be an example?
Common recommendations you might hear are things like planting crops that grow above ground, like beans or tomatoes, during the waxing moon, when the light is increasing, and planting root vegetables like carrots or potatoes during the waning moon, when the light is decreasing.
Right. Is there actually scientific evidence for this, though?
Well, that's where it gets tricky. While the practice is deeply ingrained in agricultural tradition and folklore, the scientific evidence supporting a strong, consistent effect of lunar phases on plant growth is actually quite limited and often contradictory. Some studies find small effects, others find none.
So more tradition than proven science, perhaps?
It seems that way for the most part, yes. But its widespread historical presence is really interesting in itself. It shows just how closely early societies observed the skies and tried to integrate those celestial rhythms into the most essential aspects of their survival, like growing food.
It paints this picture of a world that was just deeply intrinsically connected to these natural rhythms of light and dark, day and night, sun and moon.
Exactly.
And then came the electric light bulb, and everything changed. How has this explosion of artificial light really disrupted that ancient balance?
Fundamentally, the introduction of widespread, readily available artificial light has profoundly altered the natural light-dark cycle that humans, and indeed most life on Earth, evolved with over millennia.
And the biggest impact is at night, right?
Yes, one of the most significant consequences is the disruption caused by what scientists call Allen artificial light at night. Especially, as we touched on earlier, the blue light emitted from our electronic screens, and also from many modern energy-efficient LED light sources used in homes and streetlights.
Because it messes with melatonin.
Precisely.
Yeah.
As we discussed, blue light is a powerful suppressor of melatonin production. So exposure to it in the evening and at night makes it harder for us to fall asleep, and it reduces the overall quality and restorative function of our sleep.
And the negative effects of that go way beyond just feeling tired the next day, don't they? You mentioned health problems.
Absolutely. Chronic disruption of our natural sleep-wake cycle, our circadian rhythm, and the related suppression of melatonin have been increasingly linked in research to a whole host of health problems.
Such as?
Things like sleep disorders, obviously, but also increased risk of depression, weight gain and obesity, metabolic issues like type 2 diabetes, cardiovascular disease, and there's even emerging evidence suggesting links to some types of cancer.
Wow, that's serious.
It is. The American Medical Association has even issued guidance, pointing out that certain types of white LED streetlights, because of their high blue light content, can have a greater impact on our sleep rhythms than older forms of street lighting, like high-pressure sodium lamps.
Oh.
And studies looking at residential areas have linked brighter nighttime lighting levels to people reporting shorter sleep times, more dissatisfaction with their sleep, excessive daytime sleepiness, impaired cognitive function during the day, and even a higher risk of obesity.
It really sounds like we've inadvertently traded the natural healthy light cycle for a whole new set of modern challenges. And then there's the separate issue of light pollution itself, just the sheer amount of wasted light.
Yes, exactly. Light pollution is another really significant consequence of our, frankly, overuse and often misdirection of artificial light at night. It takes several forms that people might recognize.
Right.
There's sky glow, that's that diffuse brightening of the night sky over urban and suburban areas that completely washes out the stars for most people. There's glare, which is excessive, often uncomfortable, or even blinding brightness from poorly shielded fixtures. There's light trespass, where light spills unwantedly onto neighboring properties or into windows where it's not needed or wanted. And then there's light clutter, which is just this excessive, confusing jumble of bright lights, often seen in commercial areas.
And light pollution isn't just about astronomers being annoyed they can't see faint galaxies, is it? It has broader impacts.
Not at all. It has direct negative effects on human health, again, by contributing to circadian disruption and melatonin suppression. Glare specifically can reduce visibility, creating safety hazards for drivers and pedestrians, especially older individuals whose eyes are more sensitive.
And wildlife.
And it has really significant negative impacts on wildlife. It disrupts their natural behaviors, foraging, breeding, migration patterns. Think of sea turtle hatchlings getting disoriented by beach lighting and heading inland instead of towards the sea, or migratory birds being drawn off course by brightly lit buildings.
Right.
Ecologically, it can harm entire habitats and ecosystems by altering predator-prey relationships and disrupting nocturnal pollination. Plus, all that wasted light pointing upwards or outwards is a huge waste of energy, contributing to unnecessary carbon emissions and economic costs.
It really feels like we've created a bit of a mess with all this artificial light, disrupting ourselves and the natural world. But is there a way forward? Can we use technology itself, maybe something like AI, to help us find a better balance?
That's a really interesting and hopeful direction, actually. Artificial intelligence, AI, offers some really powerful possibilities for, first, better understanding this complex relationship between light and life, and second, potentially counteracting some of the negative effects of artificial light while still allowing us to benefit from its uses.
How could AI help us understand it better?
Well, AI excels at analyzing vast, complex data sets. So it could process huge amounts of information on things like people's daily light exposure patterns, from sensors or wearables, their individual biological responses tracking things like melatonin levels, sleep quality, even mood reports, and correlate all that with environmental factors like the type and timing of artificial light they encounter.
So it could find patterns we wouldn't spot otherwise.
Exactly. AI could help us uncover much more nuanced insights into precisely how different characteristics of light intensity, color spectrum, timing, duration affect our health and behavior on an individual or population level. This could lead to much more targeted and effective lighting strategies and interventions. Instead of just broadly saying blue light is bad at night, AI could help us fine-tune our light exposure for optimal well-being.
Okay, so instead of just having simple on or off lights or maybe a dimmer, AI could help create lighting that's much more dynamic and in sync with our natural needs throughout the day.
Precisely. This is the core idea behind something called AI-driven human-centric lighting, or HCL. These are essentially smart lighting systems designed to dynamically adjust both the intensity or brightness and the color temperature of indoor light throughout the day.
To mimic natural daylight?
Exactly, to mimic the natural changes we experience with daylight outdoors, thereby helping to support our natural 24-hour circadian rhythms. AI algorithms could potentially personalize these lighting environments based on things like the user's known preferences, their predicted circadian phase based on sleep schedules or activity patterns.
Wow.
Even real-time data about whether a room is occupied, and potentially even biometric feedback from wearable devices like heart rate or activity level.
So it could be like having my own personalized sunrise and sunset generated by the lights in my office or home, perfectly tailored to my own internal clock.
That's the vision, yes. AI could trigger brighter, cooler-toned light in the morning to promote alertness and focus, and then gradually transition the lights to warmer, dimmer hues in the evening to signal the body to wind down and prepare for rest, facilitating natural melatonin production.
What are the potential benefits of that?
The potential benefits are pretty substantial. Things like enhanced productivity and concentration during the day, reduced visual fatigue and eye strain, improved sleep quality at night, and potentially an overall enhancement of mood and general well-being.
So it's about making artificial light work with our biology instead of against it.
Exactly. By creating indoor lighting environments that are much more in harmony with our fundamental biological needs, AI could play a really vital role in mitigating some of the negative health consequences of our modern reliance on artificial light, and ultimately help create healthier indoor spaces for working and living.
That sounds incredibly promising. A way to maybe get the best of both worlds. Now, before we wrap up, let's just take a moment to reflect on the bigger picture here. Light, both sun and moon, has clearly been more than just a physical phenomenon for humanity. It's carried so much symbolic and philosophical weight throughout history.
Indeed, it really has. Light has held this incredibly deep, metaphorical, and philosophical significance across almost all cultures and throughout recorded history. It's very often used to represent profound concepts like truth, knowledge, wisdom, enlightenment.
Right, shedding light on something.
Exactly. It serves as this powerful, almost universal symbol for understanding and clarity in various philosophical and spiritual traditions. Light is frequently associated with purity, with divinity, sometimes with the very source of existence or creation itself.
And the cycles.
And the cyclical nature of sunlight and moonlight, the daily rising and setting of the sun, the monthly waxing and waning of the moon. These rhythms have also been deeply linked to fundamental ideas about time, about renewal, about the interconnectedness of life, death, and rebirth.
So it's just deeply, deeply woven into our very understanding of ourselves and our place in the cosmos.
Exactly. The fundamental role of light in literally sustaining life on Earth. And also in shaping our primary perception of reality through vision, it naturally leads us to consider these deeper, more existential questions.
How so?
Well, the daily cycle of light and darkness mirrors those larger rhythms of activity and rest, consciousness and unconsciousness, perhaps even existence and non-existence, or life and death. It can prompt reflection on the transient nature of our own lives within these larger cycles. And, connecting back to why we even explore topics like this often, the underlying motivation is an interest in alleviating suffering or improving the quality of human life. That aligns with philosophical perspectives that prioritize reducing pain and enhancing well-being. So understanding natural light's impact, both positive and negative, can be seen as part of this broader pursuit.
This has been a truly illuminating deep dive, if you'll pardon the pun, into the world of natural light. Just incredible how much it touches. To try and bring it all together, what are the absolute key takeaways you'd like listeners to remember from our discussion?
Okay, well, I think the first thing is just the sheer, enduring, and multifaceted influence of natural light on literally every aspect of our existence. Our biology, our psychology, our culture, our history, even our philosophical thought. It's fundamental.
Right.
Second, while artificial light has obviously brought enormous benefits and conveniences, its widespread use has also profoundly disrupted our ancient, evolved relationship with the natural light-dark cycle. And this disruption carries tangible negative consequences for our health and for the environment. But third, there's promise. The emergence of technologies like AI-driven human-centric lighting offers a potential path forward, a way to mitigate some of these harms and enhance our well-being by designing artificial light that more closely mimics the beneficial patterns of natural daylight, working with our biology.
Okay, biology, disruption, and potential solutions. Anything else?
Just maybe a reminder that as we develop these powerful new ways to manipulate light, we also need to carefully navigate the ethical dimensions, thinking about informed consent for light therapies, preventing misuse, ensuring equitable access, and also addressing the very real privacy and security concerns that come with increasingly smart lighting technology that collects data about us.
Excellent points. A powerful reminder that even something as seemingly simple and fundamental as light requires our conscious attention and thoughtful management in this modern world. Thank you so much for sharing all this insight.
My pleasure. It's a fascinating topic.
And for you, the listener, perhaps something to consider. How can you consciously reintegrate some of the benefits of natural light back into your own modern life? Maybe just being more mindful of your light environment throughout the day and night? Or perhaps just pondering those deep, ancient philosophical connections between light and the human condition? Until next time on The Deep Dive.
This is DigitView.